However, this discussion would not be happening if there were no potential solutions. With determination, humanity can develop and implement a program for degassing the plume, drawing on the expertise of specialists from around the world. The goal of such a program would be to minimize the impacts of the Siberian plume on humanity by reducing lava and gas pressure in the secondary magmatic chambers and preventing large-scale, uncontrolled lava flows. Achieving this would require close international cooperation and the combined efforts of scientists and engineers globally. The program could simultaneously pursue several directions. 1. Establishing a monitoring network. It is necessary to establish a network of high-sensitivity sensors and satellite monitoring over seismic and thermal activity in this region. This will allow timely detection of secondary magmatic chamber intrusion zones. Conducting detailed mapping of secondary magmatic chambers using seismic exploration methods will be required. It will be vital to preliminary estimate the pressure and the volume of magma within each secondary chamber. Next, it will be necessary to drill research and monitoring holes and install pressure, temperature, and seismic activity sensors in anomalous zones. 2. Developing controlled degassing and magmatic channel blockage technologies. It will be necessary to develop a plan for drilling inclined deep boreholes up to 5 miles or 8 kilometers in depth in safe zones. Detailed trajectory calculations will be required to ensure the boreholes accurately reach secondary magmatic chambers. Drilling technologies resistant to high temperatures and pressure must be utilized. This includes using heat-resistant materials to reinforce borehole walls and establishing a monitoring system to track pressure and temperature within the boreholes for safety and effectiveness. A process for diverting gases and lava must be carefully planned, involving step-by-step pressure management within secondary magmatic chambers through a system of boreholes. This requires controlling the degassing rate to prevent sudden pressure changes and utilizing compressor systems to regulate gas pressure. Filtration and cooling systems will be necessary to prevent the release of toxic substances into the atmosphere. The extraction of the lava and gases will continue until the pressure in each chamber is stabilized. A plan for a targeted nuclear explosion in specific boreholes must then be developed to seal the layers of secondary magmatic chambers. This approach aims to prevent excessive magma from reaching the surface and minimize ash emissions. Gradual pressure release will ensure stability of Siberia and protect key populated areas, although Norilsk and its surrounding settlements may remain at risk. During the process of diverting lava from the chambers, efforts must be made to control its flow as much as possible. Lava should be directed through specially prepared channels towards the Arctic seas. Additionally, a program should be developed to utilize magma for construction purposes, such as creating artificial islands or reinforcing coastlines. 3. Evacuation of the population. A system of early warning must be implemented, along with the development of evacuation plans for unforeseen emergencies. Additionally, a structured plan for the safe evacuation of people from high-risk zones will be required. This plan should include measures for adapting and socially supporting evacuees, considering the possibility of long-term relocation. 4. Preservation of infrastructure. Plans must be developed for the protection and evacuation of strategic facilities from areas at risk of lava inundation. This includes establishing secure storage facilities in safe zones for the evacuation of the region's critical resources, such as oil, gas, non-ferrous and precious metals, ores, fertilizers, food supplies, water, and medical supplies.